Alright, today we're going to continue on with 9.4, but most of this is actually just going to be review for our quiz that we have coming up soon. So we just want to do a little bit more practice and really try to master these trig functions. So, first example, I want you to use your calculator, or you have to use your calculator in this case. Find theta in both radians and degrees between 0 and 360 and 0 and 2 pi, including 0, not including 2 pi, including 0, not including 360. Round your answers to 4 decimal places. So you have tangent of theta is 1.2 and sine of theta is negative 0.75. So remember, we've done a lot of problems like this where the angles are on the unit circle. These angles are not on the unit circle, therefore that's why I'm telling you have to use your calculator. And also don't forget you have to be conscious and aware of what quadrants the calculator is going to give you answers in. So keep that in mind. So pause the video, find 2 angles for each of these in both radians and degrees. So each should have 4 total answers. And then unpause when you're ready to check your work. Okay, so if we look at the first one here, tangent of theta equals 1.2. So I want to think to myself, where is tangent positive? Well, tangent is positive in quadrant 1 and quadrant 3. Okay, so let's on our calculator, if I do theta equals tangent inverse of 1.2, and if my calculator's in radians, I get 0.8761. That's an angle in the first quadrant. So that's one of my answers. That also is my reference angle in radians. If I do the same thing, theta equals tangent inverse of 1.2, but I change my mode to degrees, I get 50.1944 degrees. Again, I know that's in the first quadrant because it's the same as this angle. It's also my reference angle. So here I have 2 answers and the reference angle right away, so that helps. So now I want to ask myself, so what is the angle in quadrant 3 with the same reference angle? Well, if I'm in quadrant 3 and I have this reference angle, that means that I'm going to add that to pi to get radians, and I'm going to add it to 180 in degrees to get degrees. So my other 2 angles are going to be 4.0177 radians and 230.1944 degrees. So remember, these 2 angles here are actually the same angle. This is just in radians and this is in degrees. Just like these 2 angles here are the same angle. This is in radians and this is in degrees. Okay. Now with sine, here sine of theta equals negative 0.75. Well, sine is negative in quadrant 3 and quadrant 4. So if I do theta equals sine inverse of negative 0.75, and I'm in radians, I end up with negative 0.8481 radians. This is not within my solution range. This is not between 0 and 2 pi. However, it does give me the reference angle. It tells me that the reference angle is just 0.8481. Same thing in degrees. If I do theta equals sine inverse of negative 0.75, but I'm in degrees, I get negative 48.5904 degrees. This is my reference angle. So now to find the actual angles, since I know I want to be in quadrant 3 and quadrant 4, to find the angle in quadrant 4, I subtract the reference angle from 2 pi, so I get 5.4351. And to find the angle in quadrant 3, I add the reference angle to pi. So I get 3.9897. These are my radian answers. In degrees, I do the same thing, but I subtract from 360 and I add to 180. So when I subtract from 360, I get 311.4096 degrees. And when I add to 180, I get 228.5904 degrees. So this is an angle in the 3rd quadrant. This is an angle in the 4th quadrant. Here in radians in the 3rd quadrant, and here in the 4th quadrant. Next one. So here's a word problem. The normal daily temperature, T in degrees Fahrenheit, in Savannah, Georgia, can be approximated by this equation, where little t is the time in months, with t equals 1 corresponding to January. I want you to find the normal daily high temperature for February, June, and October. So pause the video and unpause when you're ready to check. Alright, so this is just another exercise in plugging this into our calculator. We need to make sure we do this correctly. I actually put the function into y1 and then just use the table to find t of 2, t of 6, and t of 10. But you could do it each individually, so I showed for t of 2 what you would plug in. February is the 2nd month, June is the 6th month, and October is the 10th month. And so we end up with 62.537 degrees for the normal daily high temperature for February. 90.163 degrees for the normal daily high temperature for June, and 76.35 degrees for the normal daily high temperature for October. Also note, when you're doing this, your calculator should be in radians. And again, this goes to most things in trig when they're modeled using, or most applications when they're modeled using trig are in radians. So if you got different answers, check to make sure your calculator was in radians. Next one, find the secant of theta given that cotangent of theta is -7 and the sine of theta is greater than 0. So pause the video, come back when you're ready to check your answer. Also, real quick, going back to this problem and the previous problem as well, if you're having any calculator issues, be sure to talk to me in class tomorrow so we can help straighten those out. So again, pause the video for this problem though, check your answer when you're done. Alright, so here, if cotangent is negative and sine is positive, I know that I'm in the second quadrant, so I drew a triangle in the second quadrant. If the cotangent of theta is -7, then I can say that the adjacent side is -7, the opposite side is 1, the hypotenuse becomes 5 root 2, assuming I did my math correctly, and so therefore the secant is going to be hypotenuse over adjacent, which is -5 root 2 over 7. Alright, next one. In traveling across flat land, you notice a mountain directly in front of you. Its angle of elevation to the peak is 3.5 degrees. After you drive 13 miles closer to the mountain, the angle of elevation is 9 degrees. Approximate the height of the mountain. So pause the video, unpause it when you're ready to check your work. Alright, so we want to take this information, and the first thing I did was I drew a picture. So over here is the mountain, this is h, that's the height of the mountain I'm trying to find. I know that at some point when I look up at an angle of elevation of 3.5 degrees, I see the height of the mountain. Then I drive 13 miles closer, I look up at an angle of elevation of 9 degrees, I see the height of the mountain. I do not know this distance, so I called that x. So now I set up a system of equations. I'll tell you right now, this is not the easiest way to do this problem. You could use the law of sines, but since we haven't gone over the law of sines yet, I'm going to do this without the law of sines. So I set up an equation, tangent of 3.5 degrees equals h over 13 plus x, and tangent of 9 degrees equals h over x. So then I solved both of these equations for h so that I can substitute out for h, or that I can make them equal to each other. So 13 plus x times, or the quantity 13 plus x times tangent of 3.5 degrees equals x times the tangent of 9 degrees. Now this just becomes algebra. You could type in the tangent of 3.5 degrees and the tangent of 9 degrees into your calculator. They are not nice numbers, so instead of rounding early on, I've waited till the very end to round. But you can hopefully follow my algebra. I distributed the tangent of 3.5. I got the x's on one side. I factored out an x. I divided by tangent of 9 minus tangent of 3.5 degrees. So I end up with x equals 13 times the tangent of 3.5 degrees over the tangent of 9 degrees times the tangent, or I'm sorry, minus the tangent of 3.5 degrees. I typed all of this into my calculator using parentheses and making sure my mode was in degrees, and I ended up with x is 8.178 miles, approximately. So now I need to find h, and if you remember back up at the top, whoops, a little far, here I know that I could use either of these equations. I chose to use this one, so x times the tangent of 9 degrees equals h. Either one should give you the same answer though. So that's where I got h equals x times the tangent of 9 degrees. I typed in this to my calculator using this as x, and h was approximately 1.295 miles. This was a word problem, so I'm going to answer in a sentence. The mountain is approximately 1.295 miles high. Alright, so next one. Give the exact value, if possible, of the 6 trigonometric functions given theta equals -14 pi thirds. So pause the video and unpause when you're ready to check your answer. Alright, so we just need to figure out, well, where is -14 pi thirds? So I drew -14 pi thirds here in purple, and so from there I can see that that is also the same as 4 pi thirds, so they are coterminal angles. So I know if I think in terms of 4 pi thirds, the sine of 4 pi thirds is -√3 over 2, therefore the sine of -14 pi thirds is -√3 over 2, the cosine of -14 pi thirds is -1/2, the tangent of -14 pi thirds is √3, the cosecant of -14 pi thirds is -2√3 over 3, the secant of -14 pi thirds is -2, The cotangent of negative 14 pi thirds is root 3 over 3. Alright, next one. Find the reference angle of negative 27 pi 16ths. Pause the video, unpause when you're ready to check your work. Alright, so we should get 5 pi 16ths is the reference angle. I drew a picture here to help you understand that if you're confused, but hopefully you got 5 pi 16ths. Alright, last example. Use the trigonometric identities and basic algebra to transform one side of the equation into the other. So this is those proof type problems. Remember my favorite thing in trig. So use your identities and basic algebra and try to prove that one side does actually equal the other. This is not solving an equation. So pause the video and unpause when you're ready to check your work. Okay, so remember with these problems there's many correct ways to do them. Some are going to be quicker than others. So this is what I chose to do. First, I chose to make secant into 1 over cosine of x. And so since this has a denominator of cosine, I wanted this cosine to have a common denominator. So I multiplied cosine by cosine over cosine. So it became cosine squared over cosine. Now that I have a common denominator, I can combine this into a single fraction. I know that's a good idea because this is a single term. So I know I'm trying to get two terms into one. So I can combine the fraction. I get 1 minus cosine squared over cosine. 1 minus cosine squared is sine squared from my Pythagorean identity. And now is when I want to start to look at my answer. Well, I know my answer was sine x tangent x. So what can I do here? Well, I can say sine squared is just sine times sine. So I end up with sine of x times sine of x over cosine of x, but sine of x over cosine of x is tangent of x. So I get sine of x times tangent of x equals sine of x times tangent of x.